Good day everyone. On this video, I will show you how to use the Gauss Jacobi and Crout'S method in solving system of linear algebraic equations in MATLAB. So consider the system of linear algebraic equation given by these equations, which can be written in the matrix equation form as Ax is equal to b, where A is the coefficient matrix, the x is the solution matrix which to be calculated, and the b is the constant matrix. First, I will explain what is Gauss Jacobi iteration method. In numerical linear algebra, the Jacobi method is an iterative algorithm for determining the solution of a strictly diagonal dominant system of linear equations. Each diagonal element is solved for and an approximate value is plugged in. The process is then iterated until it converges. This algorithm is a stripped-down version of the Jacobi transformation method of matrix diagonalization. The method is named after Carl Gustav Jacob Jacobi. Uh, these equations are an example of a diagonally dominant. So when we say diagonally dominant, the first equation must have a first term which is greater than the absolute total value of the second term and the third term. While the second equation must have a second term that is greater than the absolute value of the first term and the third term. And last one equation is it must have a third term that is greater than the total value the total absolute value of the first term and the second term. The other method that I will discuss on this video is the Crout'S method. In linear algebra, the Crout matrix decomposition is an LU decomposition, which decomposes a matrix into a lower triangular matrix that is represented by an L and an upper triangular matrix that is represented by U. Although not always needed, a permutation matrix P. It was developed by Prescott-Joran-Crout. So for Crout's method, the matrix L and the matrix U are given in this scenario. So for LU decomposition, AX is equal to B. So we will let A is equal to LU, which matrix L is the lower triangular matrix of the given equation, while the matrix U is the upper triangular matrix of the given equation. So letting A is equal to LU yields an LU times X is equal to B. Let UX is equal to Y, and will yield to the LY is equal to B. So on this video, I will use the MATLAB language. MATLAB is a proprietary multi-paradigm programming language and numeric computing environment developed by MathWorks. MATLAB allows matrix manipulations, plotting of functions and data, implementations of algorithms, creation of user interfaces, and interfacing with programs written in other languages. We will use this example on solving and using the two methods. 19x1 minus 13x2 plus 4x3 is equal to 111. 4x1 plus 22x2 minus 13x3 is equal to negative 128. 8x1 plus 8x2 plus 17x3 is equal to 10. So I already prepared the codes for the two methods. The first one is the Gauss Jacobi iterative method. First is I put my name and then a method I will use. So for the dashboard, let's first define the matrix A and matrix B. So and defining the matrix A and matrix B, I use the code on this part. And also I also add the tolerance, which is equal to the 1 times 10 raised to negative 6. For the code on solving AX is equal to B using Gauss Jacobi iteration method. The first I did is to determine matrix side. I also input this code so it will reflect when the equation is not diagonally dominant equation. For the next one is check for diagonal dominant. I also add the initial guess, which we can change um, by representing it by 0 and 1. Also, to calculate the diagonal matrix, I put the code D is equal to diagonal A to represent the diagonal on this equation. For the main loop, I also add this code to compute the error on this solution. And for the final answer, I put this code to display the answer. Okay, so let's run the code. The first one is we need to enter the size of the matrix, which is 3. Then let's define the matrix A. Let's input the value that is given 19, -13, 4, 4, 22, -13, 8, 8, and 17. On defining matrix B, we also need to put the value of it. For the value of it, let's put the value 111, -128, and 10. So we can see, and the answer is after 41 iteration, we get we get the value of x, which are 2, -5, and 2. We can also check the value of the diagonal. So let's put the variable d to check the value of it. We can also check the value of matrix A and the matrix B. The next one is the Crout's method. Um, uh, First, I also put my name and the method I will use, which is the Crout's method. On the first part, I also need to define the matrix A and the matrix B. And for the LU decomposition, I first initialize the X and Y with zeros. The first column of L and U, and the second column of L and U. And don't forget to add 1 on it to have an increment. The second one is to initialize the diagonal entries to 1. And for the final, to display the value of L and U, I put this code to represent it later. And I also added the formulas for solving using LU decomposition in getting the value of Y and X. So let's start. Let's try to run this code. Again, we will use the example problem that we use in the Gauss Jacobi method. First one is let's enter the size of matrix, which is 3. Defining the matrix A. Let's put the value net: 19, -13, 4, 4, 22, -13, 8, 8, and 17. For the matrix B, 111, -128, and 10. So, we can see that the values of x are 2, -5, and 2, which are the same in our answer in Gauss Jacobi. We can also see the value of the upper triangular matrix, the lower triangular matrix, the value of y, and the value of x. We can also check the matrix A and also the matrix B. So, um, this is the end of this video, and I hope you learn how to use the two methods that I've discussed. So thank you for watching and have a great day.